So today we have a word problem which states that somebody's curious about the two mysterious triangles of the world, the Bermuda Triangle and the Devil's Sea Triangle. Right here we have the Bermuda Triangle, and the given sides are the A, C, and B, and they want us to find the missing angles of this triangle. So in order to do this, since we can't use the law of sine because we'll always have more than two missing components, we're gonna have to use the law of cosine. The law of cosine is c squared is equal to a squared plus b squared. Wait, b squared minus 2 times a times b times cosine of c. The first we'll solve for a angle A, which is right here, and in order to do that we'll have to to make it easier, we'll actually do C, which is right here. So in order to that we just do so it'll be 1033 squared equal to 955 squared plus 1030 squared minus 2 times 955 times 1030 cosine of C, and we'll simplify it right now. So 133 squared is equivalent to 10. Let's write that better. 1067,089, and make it easier. We'll do 955 squared plus 1030 squared, which is equivalent to 19,729,25 minus, and once again we'll do 955 times 1030 and enter that. We'll get 983,615. We'll multiply it by 2, which gives us this number. Cosine of C. Right now we're trying to solve for C, so first we'll subtract this number on both sides. And when you subtract that number on the left hand side, you get negative 905,836, and now you want to take now all you have is left with this equation right here. And what you want to do with that is, since it's together with the cosine, you want to get cosine by itself. So you would divide by this number on both sides. And right here. And when you divide that number, you get positive 0.46. It's just an estimate. We'll round to the nearest whole number. And with that, so that we'll bring that over here. So it'll be 0.46 is equivalent to cosine of C. and we want to get cos C by itself, so do that. It'll be inverse sine, so it would be cosine negative 1, 0.46 is equal to, let's put down the calculator right now, and you get 62.6, but since we're rounding to the nearest whole, we'll get 63 degrees. So C equals to 63 degrees. 63. Okay, so now that we found angle C, now we'll go for angle A. So it's the same equation, you just flip it around this time. So now it'll be A squared plus, no, A squared. Oh, we're solving for A, so let's use green. So that would be A squared is equivalent to B squared plus C squared minus 2 times B times C cosine of A. So this time we're solving for A now. So now we just plug in the numbers, which will be 955 squared is equal to 1030 squared plus 1033 squared minus 2 times 1030 times 1033 cosine of A, if it fits. Now, to make it easier, I'll just simplify. I'll just plug it into calculator. 955 squared is equivalent to 9120. Oh no, 912025. And 1030 squared plus 1033 squared is equivalent to 2127989, and you subtract by, and then you would do 1030, you multiply these two, so 1030 times 1033, you get 1063990, but you're not done yet because you still have to multiply this 2. So when you multiply by the 2, you get 2127980 cosine of A. So you do the same thing now, and now you subtract this on both sides. 2127989, and you get, when you plug that into calculator, so 912025 minus 2127989, you get negative 1215964. And now you want to divide this number to get cosine alone. Same thing right here, 2127980. And then you solve for that. So now you divide it, 7980. You get 0.57. Now same thing, if you're left with that, so it'll be 0.57 equals cosine A divided by cosine, which is inverse cosine. Inverse cosine of 0.57 is 55 degrees. So A equals 55. Now since we have those angles, we can make our lives easier and just add these two numbers and subtract the sum from 180. So let's do that. So 55 plus 63 equals 118. If you do 180 minus 118, you get 62. So that means B is equivalent to 62 degrees. So in this scenario, we're given a side angle side. So, and for this is angle A, which we solved for by adding B and C together and subtracting from 180. And so we can use the law of sine for this one because it has side angle or angle side angle, and that's going to be only having one missing component, which we can solve for. So the equation would be A of sine of A is equal to C of sine of C. If you just plug in the numbers, it would be A over sine of 101 is equivalent to 200 over sine of 10. And if you plug that in, you gotta cross multiply. So when you cross multiply, you'll get this product right here. 200 times sine of 101 is equal to A times sine 10. And when you plug this equation into a computer, you get 196 is equal to A times sine of 10. But you want to get A alone, so you divide it by sine on both sides. And once you plug that into a computer, for the missing side A, you'll get roughly around 1131, which you can input here. So A will roughly be 1131. And the point of this scenario is that we have to find the two missing sides, which are this side and this side. So now we found the side A. Now all we gotta do is find for side B. And for this scenario, we can use also the law of sine. We're still using the law of sine, except the equation will be set up differently. So this time we'll be using C of sine of C is equal to lowercase b over sine of capital B. So if we plug in the numbers, that'll come out to 200 over sine of 10 is equivalent to B over sine of 9. And let's see. And if you have to cross multiply once again. So once you cross multiply, you'll get this equation right here. 200 times sine of 69 is equivalent to B times sine of 10. And once you plug this into the calculator, you'll get 187. Oh, we're not dividing, it's just this is what you're going to get is equivalent to B times sine of 10. And as you can see right here, you want B to get B alone. So you divide it on both sides. And once you plug that into the computer, the calculator, let's see, 187 divided by sine of 10, you get roughly around 1077, and that'll be your missing side for B. So B is roughly equivalent to 1077 miles, and right here miles also. So that's how you find the missing sides for this scenario by using law of cosine. No, law of sine. Thank you.